are starting with the second session on hydro modeling, and the chair is going to be Noam Soker. You know, he's the eternal student because he's always eager to learn. Let's start.
Okay, so I hope you can see my screen, and I will give only a few slides, just to make few points, not really on result, but more on hydrodynamics. So I mentioned before, we have many type of objects with different shapes. We have the famous old nebula, even in poster, this planetary nebula is discussed. This is the Perseus cluster of galaxy in X-ray, and we see these eyes of the owl, which are, here we know these are shaped by jets because we see the jets in radio, but I will not show you. Just an example of basic same morphology. This is another X-ray cluster, and my point is that some morphologies exist in other types of objects, not only stars, even galaxies. So here we see X-ray on the left in red, and you see two bubbles, what we call lobes also, and here in purple you see the radio emission. So the radio tells you these bubbles are inflated by jets. And here, this is a famous, postcard of the Chandra Center. And you see in blue the X-ray, you see in yellow-white the galaxies in the cluster, and in red you see the radio. So clearly processing jet of some sort inflate these bubbles, okay? And here you see another shape. You see here an S shape. So you can see here S shape on the blue, and you see it in white. But this white S shape, the same shape, it's actually a planetary nebula. The planetary nebula that you can see, HB5, the same shape of processing jets. And cluster, I'm not talking about stars. I can talk also about stars. You see here stars. Here is the ring of the necklace. Romano Corradi and others worked on this. And here you see the ring of supernova 87A. I think the shaping is the same. Here in the necklace, we know there are jets. We see two clamps on opposite sides. Here are the three rings of 87A on the upper left. Below that, you see another planetary nebula. Too many people work to mention all of them. And you see this famous shape. Here we see several outer rings. Like in 87A, we have only two rings. Maybe there are weaker one we cannot resolve. This is another type of object. This is what's called red novi, or we call it ilots. But again, you see the bipolar shape, and here are the credit. Tomek has several papers on this erupting star from 1670, classified as nova, probably merger of two stars or mass transfer at a high rate. And this shape also tells me these are jets, but we don't classify it as a planetary nebula. Okay, my second point to hydrodynamical simulations are that in many cases, people present what they want to show, like a morphology or some plots of velocity, a diagram. But in many cases, if you have hydrodynamics, you have lots of information that we don't have in observations, and the information includes physics itself. For example, velocity maps. So I was very pleased to see Vikram Drukadas presenting yesterday the velocity map of his simulation. You see many vortices. In many cases, we see instability and vortices, so it is important to present the velocity. Here again, I compare two types of objects. On the left, you see a planetary nebula in yellow and red. On the right, you see a supernova remnant. The composite images on the upper left, and the other three images are lines of iron and calcium and argon, as you see, and it has what we call an H shape, like the planetary nebula. I think, again, these are shaped by jets, and we try to simulate it by jets running into the shell, namely late jets. First, spherical, more or less, or elliptical ejector, then jets. And Muhammad Akashi did this simulation. Here we present 3D image, and here we present what one observing will observe integration of density square. And we have several images, you can look in the paper, but my point is there are lots of physics here, and so it is very important to present the velocity plots in the meridional plane. The equatorial plane is z equals 0, and you see lots of vortices here, many vortices. You see one big here, but there, if we do velocity subtraction, we can see more. So my second point is present the physics. My last point is that not always when you obtain similar images in simulation that resemble observation, this implies that the mechanism is actually the same. So, so not always similar simulation and observation imply that the model is a correct one. So one should be very careful. So this is my summary of the opening, but some morphologies exist in many other types of objects. And if you can make your model with a broad scope, it will help. Present the physics. Many times when we look at the physics, not only comparing to observation, in the physics we can see much more. This will, I think, allow you to carry your results to new domains, seeing other processes, and not always similar simulation and observation actually imply that this is a correct model. We need to look for a small feature, other features, and see if it fits different evolutionary phases. So these are my few points to the opening, and if you want to refer, you can do it on Slack or later in the discussion. My last point I already put in Slack. Please go to the posters. We have also posters. I noticed that in some cases people in Zoom meetings forget about posters because we cannot force you to prepare your coffee with the posters. So this is really my last point. And so we are now to the first speaker, okay, to the first speaker in the new program that